Welcome. In this video, I'm going to solve a polynomial inequality with you and a rational inequality. In the next video, I'll solve a rational inequality, but it'll be a little bit harder. Alright, so here we go. Here are the steps I'm going to be using to solve all of these inequalities. They're a pared down version from what you have in your textbook. Let's solve x to the fourth greater than 49x squared. First step, move all terms to the left-hand side, LHS. You're going to do this by addition or subtraction. So here I subtract 49x squared from both sides to get x squared minus 49, x squared greater than 0. Step 2, I want to factor the left-hand side so I can find out where it's 0. The first thing I want to do is pull out an x squared from each term, and then I'm left with x squared times x squared minus 49, which is a difference of squares, so that factors further as x plus 7, x minus 7. So I see that whole expression on the left is 0 only when x is 0, 7, or negative 7. Those are the points I'm going to use to plot on my number line in the next step. Step 3, make a number line. Plot negative 7, 0, and 7. The original inequality is up here at the top. I'm just leaving that there to remind myself of what it is I'm trying to solve. Now we're going to make a chart. The three numbers I plotted break up the number line into 4 intervals. Negative infinity to negative 7, negative 7 to 0, 0 to 7, and 7 to infinity. I need to choose a test point or test number from each interval. It doesn't matter what point I choose as long as it's not negative 7, 0, or 7. And it has to be in the interval. The numbers I chose were negative 8 from our first interval, negative 1 from our second interval, 1 from the interval from 0 to 7, and then 8 from 7 to infinity. What I want to do is plug those numbers into the inequality and determine whether it's positive or negative at those numbers. Now, just like in the last video, I can actually find out the value at the test number, or I can just write plus minus. I'm going to choose just plus minus because it makes it a lot easier, especially when the problems get harder. For example, when I plug negative 8 into the left-hand side, one way to do this is to actually plug negative 8 in and get a number. Negative 8 squared times negative 15, that's negative 8 minus 7, and then negative 8 plus 7 is negative 1. Multiply that all out, and that's 960. But that number is meaningless. The only thing I care about is whether that number is positive or negative. So I think a quicker way to do this would be to plug negative 8 into the first factor. When we square it, we get a positive. Plug negative 8 into the second factor, x minus 7. That's going to be a negative number. And then plug negative 8 into the third factor. That's going to be a negative number. So I'll have the product of 2 negatives and 1 positive, giving me a positive number. Let's do the same thing for the other 3 intervals. When I plug negative 1 into x squared times x minus 7 times x plus 7, I get negative 1 squared, that's a positive. Negative 1 minus 7 is a negative number. And negative 1 plus 7 is a positive. A negative times 2 positives is a negative. Now let's plug 1 in. I'll get a positive. 1 squared is positive. 1 minus 7 is a negative number, and 1 plus 7 is a positive number. So again, I have a minus, 2 pluses. The product is negative. And finally, if I plug 8 in, I get positive, positive, and positive, giving me a positive. I then take those pluses and minuses and I put them on my number line over the correct interval. So a plus here, a minus here, a minus here, and a plus here. Okay, we're almost done. Now step 5 is just to determine what our answer is. We go back to our original problem and we look at it and we say, well, what are we being asked for? We're being asked for the places where the left-hand side is strictly positive. Those are going to be the intervals with the pluses over them. They will not include the endpoints -7 and 7 because that is where the left-hand side is equal to 0. And we don't have greater than 0. We don't have greater than or equal to 0. We have strictly greater than 0. Let me show you some alternative answers to alternatively phrased problems. If the problem had been greater than or equal to 0 rather than strictly greater than 0, we would have included the two endpoints -7 and 7 in our answer, and we would have used square brackets to do that. So our answer would have been like this. And then if the problem had been strictly less than 0, then we would want the two negative intervals. So -7 to 0, not including the endpoints, and 0 to 7, again, not including the endpoints. Finally, if we had had less than or equal to 0, we'd go from -7 to 0 and 0 to 7, including the endpoints. So another way to write that would be -7 to 7. All right, now let's do a problem that has a fraction in it. That would be called a rational function. We want to solve x minus 2 times x plus 4 over x greater than or equal to 0. Step 1, move all terms to the left-hand side. That's already done. Step 2, if we have a fraction or rational function, we want to factor both the numerator and the denominator. The denominator is already factored, and actually so is the numerator. The only place a fraction can be 0 is when the numerator is 0, and the only place a fraction is undefined is where the denominator is 0. So you need to know that. It's very important. That rational function there is 0 at x equal 2 and -4, and it's undefined at 0. So you take the collection of points where the function is either 0 or undefined, and those are the numbers you use to plot on your number line. So we've got -4, 0, and 2. And then we're going to fill in a chart. We've got 4 test intervals again, and we're just going to be looking at the sign, the plus minus of the left-hand side at each of our intervals by plugging in a test point. So the test points I chose are -5, -1, 1, and 3. So we'll go through maybe 1 or 2 of these with you slowly, and then you could just pause it and read the rest. When I put -5 in to the left-hand side, I get -5 minus 2, which is a negative number, times -5 plus 4, which is a negative, over -5, which is a negative. 3 negatives, multiply 2 negatives, divide by a negative, gives you a negative number. So I put a negative over my first interval. When I put -1 in to the left-hand side, I get a negative, -1 minus 2, times a positive, -1 plus 4, over a negative. 2 negatives and a positive gives me a positive. And then similarly, I get a negative in the second interval, the third interval, and a positive in the fourth interval. So my number line looks like this, and let's write down our answer. We're looking for the places where the function is greater than or equal to 0. So we want the positives, and we have to be careful about which endpoints we want to include. We want to include -4, and we want to include 2, because the left-hand side is 0 at those points. We cannot include 0 because the left-hand side is not defined at 0. And you can't have in your answer any numbers where the expression is undefined. So it's important that when you formulate your answer, you go back and you say, okay, I got to make sure I'm not including any numbers in my solution where the function's not defined. All right, and in the next video, we're going to solve this problem, which is a little bit harder because there isn't a 0 on the right, there's a 2. So that's going to require a little bit more work. All right, see you then.